Okay, so welcome everybody. I'd like to introduce to you all Mr. Brian Day with the NASA Ames Research Center. He is the Education and Public Outreach Lead for the LADEE mission, which is the next lunar mission scheduled to launch, I believe, next spring. And he's also the Citizen Science Lead for the NASA Lunar Science Institute, which is based at NASA Ames. And he's going to talk to us tonight about how you can observe the moon for International Observe the Moon Night, and like 10 days away. What are some of the lunar features we'll be able to see on the surface of the moon on that night? And he's going to give us an update on the status of, or I should say the status of current lunar science and exploration. So I'm going to get rid of our camera window here. We can make the PowerPoint window a bit bigger, and then I'm going to hand it over to Brian.
All right, very good. So let's start out with a description or an answer to the question of what is Observe the Moon Night? Observe the Moon Night is coming up on Saturday, October 8th. And this is going to be an event where people around the world will be able to gather and observe the moon, appreciate the moon. We have materials that are available to people who are holding events. But last year when we did this, we had over 500 events in more than 50 countries. So yeah, it's kind of a big deal. But it's a chance to get together, perhaps with your local amateur astronomers, and have the opportunity for the public to actually observe the moon and appreciate the wonder of the moon. So what are we going to see on the evening of Observe the Moon Night, Saturday, October 8th? Now let's see here. Andy, real quick, I'm going to need your help. How do I march through the slides here? Where's my...
Sorry, I mentioned it earlier. Do you see in the lower left of that pod with the PowerPoint, there's an arrow pointing left and an arrow pointing right? That lets you go to the next and the previous slide.
I have no such arrows.
Oh, that's because I didn't make you special enough.
Ah. Oh, I've just become special. Thank you very much. Okay. So, one of the things that, of course, you can do is go out and appreciate the moon with your unaided eye. You don't need binoculars. You don't need a telescope. The moon is one of the few objects in the sky that you can appreciate as a planetary body just with your unaided eye. So what do you see when you go out and look at the moon? Well, on that night, the moon is going to be in the phase called waxing gibbous. And this shows you the approximate phase of the moon. You'll see the shadowed portion of the moon over on the left there indicates the portion of the moon that is experiencing nighttime as seen from the Earth. And that'll actually be a lot darker than you're seeing in this version here, but it shows you how much of the moon will be illuminated. The moon's actually going to be trailing the Earth somewhat in its orbit, and it's going to be outside of the Earth's orbit as it makes its way around the Earth. One of the things you'll immediately see as you look at the moon is there are differentiations in shading. There are light areas and dark areas. The dark areas have been described as seas. We now know they are not water at all, but they are vast plains of basaltic lava. So yes, you can actually look up at the moon with your unaided eye and see different types of rock on the surface of the moon. Now, advancing to binoculars, you'll have a somewhat clearer view. And again, this is how the moon will appear on October the 8th. And as you look at the moon through binoculars, you'll be able to make out individual impact craters, and those dark areas, the seas or mare, will start showing a great deal more detail. One of the things you will realize is this circular shape common to many of the mare. The mare are actually typically formed from large impacts. These are, in many cases, very large impact basins. And as a result of those impacts, molten lava came up through cracks in the ground there at the impact sites and flooded these large impact basins. Some of the impact basins still retain their nice circular shape and even have raised rims around them, so they very easily are identifiable. Others got so inundated with lava that the lava just kind of spread out over them and around them, and some of their underlying structure is not so obvious anymore. But as you take a look, you'll see that there are a number of them. One of the larger is Mare Imbrium. It's the largest mare on the moon. that we can view that night, and it's very well defined by a raised rim of mountains, Mare Serenitatis, Mare Tranquillitatis, the Sea of Tranquility, very famous for being the site of the Apollo 11 landing, but again, very overflowing with the lava. There's no obvious basin there. But as you look across the surface of the moon, you'll see a variety of these basins. We're pointing out some of the major ones here. One of the interesting things is that these Mare units are visible very clearly on the near side of the moon, but we look at the far side of the moon and we see there are hardly any of them at all. So the near side and far side of the moon show up very differently. Now the largest of these Mare units is actually so large that it was given the term of an ocean rather than a sea, so Oceanus Procellarum. And this is something that we're going to be paying a lot of attention to. But again, with binoculars, you'll be able to look up and you'll be able to identify these individual seas and in many cases see their structural origin from impacts. Then something you should try is if you're looking at the moon with binoculars, once you've learned to see where these individual seas are, then put the binoculars down. And if your eyes are good, or if your glasses or contact lenses are good, then you should actually be able to make out some of these seas and identify them just with your unaided eye. And that's pretty neat. You're seeing impact structures on another world just with your unaided eye. I think that's pretty cool. Something else you'll see in binoculars when you look at the moon are bright craters surrounded by rays. It looks like splashes of lighter material. And these tend to be younger craters, and those splashes, those rays, are actually from excavated material that was thrown out over a large distance during the impact that formed them. The younger craters still preserve this bright ray feature. Now, younger is a relative term. Looking at the crater Tycho, Tycho has a beautiful ray structure. You'll see the streaks of bright, fine pulverized rock stretching across large portions of the lunar disk. Tycho, as a younger crater, it's only 109 million years old. Okay, sounds pretty old, but of course erosion on the moon doesn't happen that fast. But had you been around during the time of the dinosaurs, or had the dinosaurs been interested enough to be looking up at the moon, they would have seen the very interesting impact of Tycho. There are also several other bright rayed craters that are worth looking for on October the 8th. Copernicus, and also getting close to the edge there of the illuminated part of the moon, Kepler. So those are three really nice examples of bright rayed craters. Now, moving on to the telescopic view. The craters will assume, even in a very low power, will assume much more detail. And one of the things that you will notice is that the best detail that you will see on the surface of the moon comes right along this line between the day side and the night side of the moon. That's where the sunlight is coming in at the lowest angle, and so every little bump, every little ridge will cast a very noticeable shadow. Whereas getting away from that terminator, moving over toward the center of the moon or even the further limb on the right there, the sunlight is coming in much more directly. You have much flatter lighting, and so you won't see the raised features anywhere near as easily. So on this evening, or on any evening, when you're really looking at features on the moon, one of the better strategies is to concentrate your viewing along this line between day and night, the terminator, because that's where you'll get your best view. So let's take a walk along the terminator and see what we will be seeing that night. We're going to start out with where the terminator is positioned at about 8 hours universal time. So this is as people would see it in the evening if you're looking at the beginning of Observe the Moon Night in, say, New Zealand or the Far East. So that's when Observe the Moon Night begins. They're going to start first. And so one of the things that you will want to look for in the upper part of the moon are some really interesting features. One is the Gruithuysen domes, and you can see those arrowed there, as well as then an example of a flooded crater, Prince. Now, the Gruithuisen domes are really interesting examples of lunar volcanoes. Lunar volcanoes typically are anything but spectacular. Lunar lava tends to be very, very, very non-viscous, very runny. It's about as viscous as olive oil at room temperature. So as a result, it just tends to spread out. It didn't really have a chance to build tall volcanoes. But there are a few exceptions, and the Gruithuisen domes are wonderful exceptions of really nice volcanic mountains that you'll be able to see through the telescope. Now here's a LRO-based picture of the Gruithuisen domes. And one of the things we are learning is that the Gruithuisen domes are in fact different because the lava that they're formed from is more different. It's silicic. It has more silica in it, and therefore it's stickier and not as runny. Now, we also talked about the crater prints. So again, in that big Oceanus Procellarum area where we're looking, that's a big lava field, and a lot of the lava that spilled out flowed over the rims of already existing craters, and you can see Prince there is an example of that. So you can see how most of Prince was inundated. But take a look at the area above Prince here, just north of Prince, and you'll see examples of lunar rills. And these are lava channels. These are where rivers of molten lava carved their way through the terrain. So this is really interesting, and if you take a look at the heads of some of these rills, you will see actual craters that, most of the craters on the moon are impact craters, but here are some examples of true volcanic craters. So craters from whence this lava came and then flowed across the lunar surface. Really great examples here of lunar volcanism. So, moving further south along the Terminator, we get to one of the seas, Mare Humorum. And Mare Humorum is nice in that it is very clearly an impact basin. And it has raised rims around it. It has interesting features. And on the north edge of Mare Imbrium is a crater called Gassendi. Gassendi is about 110 kilometers in diameter. And it is an example of a crater that actually became partially filled by lava upwelling from the floor of the crater itself. And if you look at the floor of the crater Gassendi, you will see it is amazingly textured with wonderful cracks and rills and fractures and ridges. It's just a spectacular thing to look at. And here you can see photographs showing Mare Humorum and this big flat inundated plain. You can see, if you look along the lower left there, you can see some beautiful scarps. There are cracks. If you look at the very bottom, just bottom left, you can see it's a little bit darker. That floor is a little bit darker. And that's apparently ash deposits, volcanic ash deposits. So that's on Mare Humorum. Now take a look at Gassendi, and if you look at Gassendi, okay, we're a little bit small here in the picture, but you can actually see that there, you've got the central peaks of the crater that were formed when the crater was formed, but then they're just sticking out now above this lake of lava that rose up. But there are fractures across all kinds of wonderful sculpted terrain on the floor of this beautiful, beautiful crater. Continuing south along the Terminator, we get to something really, really strange. This is the crater Schiller. Now we're kind of near the edge of the moon, so all the craters are foreshortened. They seem to go from being circular to being kind of ellipses, just because of the geometry of how we're looking at them. But Schiller is a special case. It is truly elliptical. If you'll notice in the picture there, it is far more elliptical, far more squashed than the craters around it. That's because Schiller is in fact very oblong. It's 180 kilometers by 70 kilometers. Now that's very strange, and that's hard to really make happen. It turns out when you have a meteoroid impact on the moon, the excavation of material is done not by the object itself hitting the moon, but by the shock wave radiating from that object. And that shock wave will radiate in a circular fashion even for a relatively steeply inclined impact. So if it's coming in at a very low angle, it still will tend to make nearly a circular structure. It's only when you get to extremely low angles, maybe in the vicinity of 3 degrees, that you can get something like this. Now this actually looks like some features, and here's a closer view of Schiller. You can see it's just a really, really interesting, strangely shaped crater. It's very interesting to note that some of our probes in orbit around Mars have detected several craters that look very, very similar to Schiller on Mars. And Pete Schultz of Brown University, one of the world's leading experts on impacts, has proposed that these craters on Mars, these highly elongated craters on Mars, may in fact be the final resting places of former moons of Mars that have slowly orbited, had a decaying orbit, and so would come in at a very, very shallow angle. And so we see several examples of this on Mars. And so some lunar scientists think that perhaps Schiller is an example of where a former satellite of the moon may have actually come to an end on the lunar surface. So a very interesting area to speculate about, and it's certainly a very, very interesting object to observe. So during the course of the evening, the terminator, that line between the daytime side and the nighttime side, is going to be moving to the left as we're looking at the moon here. So you will notice that what we're looking at here is essentially how the moon is going to look now in the evening from the western coast of the United States. If you take a look to the right of the craters that we have arrowed here, you'll see that, well, we're still looking at one of the areas we had looked at before. You can see the Gruithuisen domes up near the top. You can see the crater Prince just to the right of the arrowed craters. And before, when we were looking at Prince, the terminator was going right through. It was bisecting Prince. But here you can see when we go from evening in New Zealand to evening in California, you can see how much that terminator is going to move during the course of International Observe the Moon Night. As that terminator moves to the lunar west, the illumination will become less favorable for some of those very, very fine rills just to the north of Prince. But that's okay. We compensate by exposing new and very interesting terrain. And as a matter of fact, as we look here, we see that the terminator is now crossing the Aristarchus Plateau. And the Aristarchus Plateau is truly one of these stranger places on the lunar surface. It has been a focus of attention for a long time among lunar observers as being an area where people have frequently reported seeing transient lunar phenomena, strange flashes, bright colors, and really strange transient events. Some people used to think that these were actual volcanic eruptions still happening on the moon. We think that is probably not the case now, but we have seen that there does seem to be perhaps some releasing of gas in this area. And the Apollo 15 command module detected outgassing, I believe, of radon coming from this area. So this may be some of the last gasps of internal activity in the moon. In the vicinity of the Aristarchus Plateau, we have, of course, the namesake crater Aristarchus, which is the brightest large crater on the moon. So it really stands out. Just to its left is Herodotus, which is a flooded crater. And right to the north of Aristarchus and Herodotus is an amazing feature, Schroeder's Valley. And Schroeder's Valley is probably the grandest of the rills on the surface of the moon. So here you can see a close-up view of Aristarchus, which is a classic impact crater. You can see that kind of dish shape with the central peak. You can see Herodotus to its left with the flooded plain. And above that is Schroeder's Valley, this beautiful, beautiful lava channel. It originated from that elongated crater. You can see it's kind of got a rise around it, kind of a dome. And that source crater for Schroeder's Valley is sometimes called the Cobra Head. You can kind of see why, with the Cobra Head there, at the head of the snake, and Schroeder's Valley being the body of the snake. But again, a wonderful, wonderful, exciting area of volcanic activity on the moon. Again, in its very distant past. Heading south, so you can see now you can see the Aristarchus Plateau kind of toward the top of our map. And heading south from there along the Terminator, we get to another really, really strange, interesting area. These are the Marius Hills, about 300 volcanic cones and domes, and just, again, something different than your typical lunar volcano, very low profile. In this case, they can be fairly steep. Again, let's take a look at an image that was returned to us by the Lunar Reconnaissance Orbiter. And you can see these knobby formations, really, really interesting. This had been chosen as one of the Apollo landing sites and probably would have been visited had the Apollo program not been terminated before the originally planned final mission. But if you take a look here at the terrain, you'll see, again, these wonderful knobby cones and domes, and you'll also see the areas laced with rills. The rills can be a real challenge object, but with this illumination, with the Terminator going right through this area, that's pretty optimal. So if your viewing conditions are steady, this is a fantastic area to look at on the night of October the 8th. So, why are we so interested in looking at the moon right now? Well, we're kind of enjoying a renaissance in lunar exploration. There's a term or a phrase that's often used with the moon, how the moon was looked over and then has been overlooked. After the Apollo age, we thought we pretty much understood the moon and it wasn't all that interesting. But there has been now a recent generation of new robotic explorers of the moon, and they have revolutionized our understanding of the moon. And one of the things that you'll note is that this recent flurry of activity of robotic explorers to the moon has been from a number of different countries. There is great international interest in the moon. And that's because the moon has turned out to be a far different place than we thought. One of the things that I learned in school was the moon was absolutely dry. It is bone dry, no water there at all. Well, we now know that the moon, in fact, has significant deposits of water ice at its poles. We know that the moon now, the permanently shadowed craters on the moon can be the coldest places that we have yet measured anywhere in the solar system, even colder than we measured on the surface of Pluto. There are areas on the moon with nearly constant sunlight. Now, most of the moon has 2 weeks of light followed by 2 weeks of dark, but on peaks near the South Pole, there are places that get nearly constant sunlight. And the fact that those happen to be located near areas where there may be significant deposits of water ice is very interesting. Also learned in school that the moon has no atmosphere. Well, the moon does have an atmosphere. It's very thin, but it does exist. And as a matter of fact, it is an example of something we call a surface boundary exosphere, which is the most common type of atmosphere in our solar system. Our Earth's atmosphere is kind of the exception to the rule. But Mercury has a surface boundary exosphere, the larger asteroids, some of the moons of the giant planets, and probably even a number of the Kuiper Belt objects. We know very little about these types of atmospheres. Again, it's the most common in our solar system. We know very little about them, but we happen to have one in our own backyard. How cool is that? Also, clearly the moon is far more geologically complex than we had previously thought. So the moon is a very interesting place. It is not your father's moon anymore. So, what's going on right now? Well, we have a number of probes that are conducting science around the moon. The flagship of them is probably the Lunar Reconnaissance Orbiter, or LRO. And LRO is mapping the surface of the moon in unprecedented detail. It has the Lunar Reconnaissance Orbiter camera, this wonderful camera that is getting incredibly detailed pictures that are even able to reveal the footprints of the astronauts on the moon. It's got a laser altimeter measuring the terrain, all the ups and downs of the terrain. It's characterizing the thermal environment of the moon, the radiation environment of the moon. It's able to look into these permanently shadowed areas and actually, with a kind of sophisticated night vision, see what's going on in there and even detect where there may be deposits of water ice. Another pair of spacecraft in orbit around the moon are the Artemis missions. So two spacecraft together form the Artemis mission, and they were originally part of another mission called Themis that was looking at space weather around the Earth. So they were in Earth orbit and looking at the interaction between the solar wind and the Earth's atmosphere and magnetosphere. But two of the spacecraft were then moved out of Earth orbit and have now gone into lunar orbit. So two of the 5 Themis spacecraft have now broken off and become the new Artemis mission. These two Artemis spacecraft now in orbit around the moon are taking a look at the interaction of how the solar wind interacts with the surface of the moon. Again, the surface of the moon, very different than the surface of the Earth. You don't have the big magnetic field on the moon that we have around the Earth. So it's a very, very different situation. So this is a very interesting repurposing of spacecraft. Something else we've just had happen is a wonderful launch out of Cape Canaveral. It was the launch of GRAIL, the Gravity Recovery and Interior Laboratory. We've been doing a great job lately of studying the surface details of the moon. But what GRAIL is going to do is it's going to look down inside the moon. It is actually going to map the interior of the moon from core to crust. And the way it's going to do that is the fact that we're going to have 2 spacecraft that are going to be orbiting the moon essentially in formation. And they're going to be ranging each other with a microwave link, so they will be able to monitor their separation to within less than a micron. Very, very, very precise measurement. And as the leading spacecraft flies over say an area of increased mass, that gravity is going to pull the spacecraft, and the distance between the 2 spacecraft will increase. And then as that leading spacecraft has gone past that concentration of mass, it will slow down, and then that second spacecraft is going to be accelerated. So you're going to see this variation in distance between the lead and the trailing spacecraft. And those are going to tell us about variations in subsurface distribution of mass. And as they make multiple orbits around the moon, that can all be integrated together into this very detailed map of the interior of the moon. Now, again, there are 2 spacecraft in the GRAIL mission. There are 2 spacecraft in the Artemis mission. And, of course, we have LRO. So at the time that the GRAIL spacecraft actually go into lunar orbit, that'll be around New Year's, we are going to have 5 spacecraft from NASA conducting science from lunar orbit. That is very exciting, and that's an indicator of how interesting the moon has turned out to be. Looking a bit into the future, we have, as Andy mentioned at the beginning of this, we have another mission coming up, LADEE, the Lunar Atmosphere and Dust Environment Explorer. It's scheduled to launch in 2013. And what LADEE is going to do is it's going to go into orbit around the moon, and it is going to actually dip down and fly through the lunar atmosphere. It's going to sample that atmosphere. It's going to tell us what it's made of, how it's distributed, how it changes over time. It is also going to look for possible fountains of levitated dust. Dust may be levitated electrostatically on the moon. We've seen evidence of this from some of the instrumentation left behind by Apollo and observations by Apollo astronauts and even by the Surveyor spacecraft. So a very exciting mission coming up in 2013. Now, and I've seen some discussions about this in the chat area. It turns out that the Draconid meteor shower is also going to be peaking on Observe the Moon night. So that is a really neat thing. Not only do we have the Draconids, but we may have a very special occurrence of the Draconids. What looks like may happen, we have a prediction that the Earth will pass through a cloud of dust that broke off from the 1900 passage of the parent comet, Comet Giacobini-Zinner. And if this prediction holds true, we could see rates as high as 600 to 750 meteors per hour. So that's 10 times what you would typically see from the Perseids. This could be very spectacular. It is predicted that it would occur in a short outburst lasting about 3 hours long, which would peak around 20 Universal Time. What that means is that observers in Europe and North Africa will be favored for viewing this. At the time of that peak, it's probably going to be daylight here in North America. But again, we have observers around the world, so we are hoping that people who are favorably positioned will go out and observe the meteors associated with Comet Giacobini-Zinner. One of the really interesting possibilities, since this stream does come down upon us from the essentially from the north, there is the chance that on that shadowed area of the moon, on the kind of moon's northwestern quadrant, in that area that is still dark, using a telescope you may be able to see flashes of impacts from Draconid meteoroids actually hitting the surface. Now I've got to tell you, this is far from an ideal circumstance. Seeing the meteoroid impacts on the surface of the moon is actually something that is easier than you might think, but it really does require the proper phase to see to best advantage. And we've got a really largely illuminated moon here, so there's going to be a lot of glare. So this is not an ideal circumstance, but still it is something that I know there will be people who will be going out and looking. Now, because the moon is in a trailing position, we would expect to see the maximum of the activity on the moon occurring probably a couple of hours after the maximum activity here on Earth. So this is a very exciting addition to observe the moon night. So again, I see one of the questions is, what is the Draconid meteor shower? The Draconid meteor shower is a shower that occurs every year when the Earth passes through the orbital path of a comet, Comet Giacobini-Zinner. And as this comet flows through the solar system, as it makes its loops through the inner solar system, of course, you've seen pictures of comets, and it develops that nice, beautiful streaming tail. Well, that trail is ice and dust and debris and some gases being essentially volatilized, being heated by the radiation from the sun and the ice of the comet. The comet is actually just a big dirty snowball. It vaporizes and it leaves this trail of debris behind. So even after the comet has passed, we have this trail of debris, of dust and ice floating in its path. And on an annual basis, we can pass through that path. And it looks like perhaps this year we may pass through an especially good clump of debris. So let's see. At this point, I think what we'll do is we'll break for questions. And it looks like we probably have a few questions here. Let me try and scroll up and see what all I've missed. Okay, so Pat is, okay, so first, is Oceanus Procellarum the only one given an ocean name? Yes, it is. There's only one ocean on the moon. There are a number of mare, but there are there's definitely only one ocean. Why does the ice not sublimate, evaporate, given billions of years to do so? Again, when we take a look at these permanently shadowed areas, the temperature is exceptionally low. So there undoubtedly could be some sublimation. There can be sputtering. It is an intensely radioactive environment out in space. So there is going to be some probable loss of material, of ice from these areas, but there will also be accumulation. We now understand that there may be a number of sources for the water on the moon. This probably wasn't, most of it did not form originally with the moon, but is a result of external sources. So meteoroids, like carbonaceous chondrites that contain a significant amount of water, and cometary material hitting the moon. Those can all contribute a significant amount of water to the lunar environment. And as we noted, the moon has an atmosphere, and that atmosphere may actually play a role in a lunar water cycle. So again, we have essentially continued influx. Another possible source could be, of course, the solar wind. The solar wind, high-speed hydrogen atoms impinging upon the surface of the moon. They could interact with oxygen atoms that derive from silicate minerals on the surface of the moon. So those hydrogen and oxygen atoms could join together and actually form water molecules. And some of that, some evidence of that came actually from the Indians' Chandrayaan probe and the NASA Moon Mineralogy Mapper experiment on board. Is there a possibility to find liquid water underground at the poles where the sun's flux is almost in contact, so coming in very, very low? Probably not, no, not liquid water. The conditions on the moon, the atmospheric pressure is just too low, and but you're on a really, really, really good line of reasoning there. One of the things that we think may be happening is even outside of these permanently shadowed craters, just beneath the surface, in areas where the sunlight comes in only very, very, very low and for a limited amount of time, there may be permafrost. So water may exist even outside those permanently shadowed craters, just beneath the surface in essentially a permafrost. So that's something we certainly are very, very interested in exploring more. Is it possible to see a shadow of one of the orbiters while observing the moon? Our orbiters are really, really small. And unfortunately, the shadow that they might cast would be far too small to be observable from here on Earth. What is the significance of Silica Dome? Let's see. Let me scroll down here. I had it here. What is the significance of silica domes? is that the same as granitic rock? No, it's not the same as granitic rock, but so here on Earth, we have different forms of lava. Basalt is something you're probably familiar with if you've gone through some areas of the desert Southwest, like in Arizona and New Mexico, or especially in Hawaii. You'll see lots of basalt. And basalt is low in silica content. It is very, very runny. Then we also have another type of lava called andesite. And andesite has a higher amount of silica, and as a result is thicker. And andesite gains its name from the Andes Mountains in South America, where you have a lot of this andesite erupting and forming very tall, steep volcanoes. Another then going a step up in silica composition, even more silica, you'll get to dacite, D-A-C-I-T-E, and a good example of a dacite volcano here in the United States is Lassen Peak in the Lassen Volcanic National Park. And then the thickest, the most silica-rich is rhyolite. And rhyolite is so thick that it can result in very, very explosive eruptions. So on Earth, we have this wide gradation in types of lava. And a lot of that is tied to the effects of continental drift, of plate tectonics. We know that the moon itself really doesn't have plate tectonics, and that's one of the reasons why volcanism on the moon seems to be fairly monotonous. Just a lot of basalt wherever you look, runny basalt. But again, there are these few exceptions, and the exceptions are the things that make things really, really interesting. So that's why we find something like the Gruithuisen domes interesting, is because they stand out for being different. Will anyone else be observing from outside the U.S.? We have someone with students in Tanzania. Excellent, Chuck. As a matter of fact, if you go to the International Observe the Moon site, so observethemoon.org, and take a look on that front page, you will see a wonderful interactive map showing where people have registered to have Observe the Moon Night events all around the world. And so we encourage you to go to that map to find out where there's going to be an event near you, and maybe even decide to hold an event yourself. So if you want to add to that map, there's still plenty of time to do so. So I would really encourage you to do that. If Pat is saying if there's no magnetic field, how does one navigate on the surface? Where is north? Yeah, so when Robert mentions north, matches up to our north. So we're not talking, of course, about a magnetic north on the moon. We're talking about a north as with regards to the moon's rotational pole. Let's see. Will we be having another seminar prior to INOM on October the 8th? I'm going to leave that one to Andy. Andy will be able to tell us what is coming up on my moon. Let's see, when were the first photos taken of the moon that showed clear craters? Oh my God, I'm trying to remember. There were pictures taken of the moon showing craters well before I think even before the advent of film. So it was essentially metal plates, as I recall, that had been coated with a photosensitive material. So even more than 80 years ago. And then, so the question is, perhaps have you, I assume, oops, close. Not sure what's happening here.
What you got, Brian?
Oh, okay. Just an Adobe Flash settings window came up, but I'm through it now. You can still hear me, right? Can you still hear me? Okay, good. So let's see. Just trying to see, trying to scroll through some of these here. Yeah, someone mentions that Night Sky Network, a lot of people will be broadcasting live that night. That's excellent. We have if the Lunar X Prize team left a brilliant strobe light on the moon that could be commanded to flash, would we see it in binoculars? I would think binoculars would not be, it would have to be a pretty ridiculous strobe to see with binoculars. But I would think, you'd need a fairly significant telescope. Let's see. So in terms of features beyond the obvious Maria, what would be the best to put our scopes on, the easiest for novice observers to discern? Again, I would take a look at some of the, craters like Gassendi is going to be a really nice crater to look at. Copernicus, Kepler, as Aristarchus comes into view. Watching sunrise across Aristarchus will be a wonderful experience that everyone will enjoy. So I would highly recommend that.
Brian, further up, somebody asked, what are the chances of seeing LRO or other satellites that are orbiting the moon?
From Earth, pretty much non-existent. LRO is remarkably, it's small, so it would be very difficult to see. Now, I don't want to say these are absolutely impossible, because one of the things that did happen back with the L-Cross mission is we had amateur astronomers who were actually tracking L-Cross in space and imaging it at the distance of the moon. So it is not impossible, but it would be especially challenging because when we were imaging L-Cross, it was against a nice dark sky. With the moon, the moon tends to be pretty glaring. So while I'm not going to say it's impossible, it would be a huge challenge. Also keep in mind that LRO is dramatically smaller, and so same thing for the Grail spacecraft and the Artemis spacecraft. They are dramatically smaller than L-Cross was. L-Cross, when we were looking at L-Cross, we were looking at the shepherding spacecraft combined with the Centaur upper stage of our moon rocket, and that's about the size of a school bus. So that was a big object, and it was showing up at about magnitude 15. These are much smaller objects, therefore they will be much, much dimmer, and they will be seen in close association with this big old bright moon. So I would say it would be very, very, very challenging. But I've learned enough about the capabilities of amateur astronomers and the amazing things they can do. I would never say it's impossible. Are there any questions here that I have missed? Oh, can we talk about the strange goings-on in Aristarchus? Well, that's a good question. A lot of these early transient lunar phenomena observations were kind of written off as either crackpot or perhaps the lack of skill of amateur observers as seen by members of the professional community. But interestingly, as people at, I believe it was the Lowell Observatory, so professionals were doing mapping in advance of the Apollo mission, some of them actually started seeing some interesting flashes and glows in the region of the Aristarchus Plateau. So there's been a lot of controversy, but the fact that there is some evidence of outgassing, and one of the things that we have now come to conclude is that the moon still is outgassing. There's release of a number of gases from the interior of the moon, argon being one of them. So, the statement that I often heard in school long ago of the moon being geologically dead is probably a real overstatement. As a matter of fact, reinterpretation or re-examination of some of the seismographic evidence or data that came back from the Apollos shows that the moon has a number of different types of earthquakes. Some are associated with meteoroid impacts on the surface. Well, you'd expect that. Some are associated, come from very, very deep and associated with the tidal stretching of the moon. Some are associated with thermal expansion and contraction of rock near the surface of the moon. But there's some that we don't really have a good explanation for. And some of these kind of mysterious earthquakes can get up to, better than magnitude 5, and can have a duration of over 10 minutes. So if you're in a magnitude 5 earthquake that is lasting for over 10 minutes, you would quickly conclude that the object you are standing on is not geologically dead. So this is one of the real good reasons to have a mission like GRAIL heading to the moon and giving us a look at what's going on beneath the surface. So GRAIL is taking a very leisurely pace. It's taking essentially the lowest fuel utilization path to the moon, and in doing so, making use of the Lagrangian points. And in doing so, it's going to take a while to get there, but we anticipate the GRAIL probes going into orbit. I believe it's sometime right around New Year's. So, Louis, I see you asking, eagerly awaiting that data. So you're going to have to wait until next year. So in 2012, we should start seeing some really, really interesting stuff. How often are new impact craters created that can be seen in large telescopes? Seeing the craters that are formed themselves, that's actually fairly difficult. But what turns out to be significantly easier is seeing the flashes, the thermal flashes that are created when meteoroids slam into the moon. Now, in doing so, you don't want to look at the illuminated surface of the moon. You want to look at the nighttime side of the moon. And it turns out you don't need a really large telescope. Actually, a telescope in the range of 8 inches to 16 inches in aperture is ideal. And there's a program operated by NASA's Meteoroid Environment Office that works with school observatories and amateur astronomers and is encouraging them to become observers, looking for these flashes of meteoroid hits on the moon. Now, with the LADEE mission, we are especially interested in this because we believe that these meteoroid impacts could be significant sources for the lunar atmosphere. And so what we would love to do is during the course of the LADEE mission, as LADEE is flying through that lunar atmosphere and measuring its density and composition and structure, if we could at the same time have people watching for these impact flashes, then we would be able to correlate, ideally, lunar impacts with any changes we see in the structure and composition of the lunar atmosphere, and therefore gain a better understanding of the role of impacts as sources for the lunar atmosphere. So this is an opportunity for you as an amateur astronomer to actually play a very important role in true lunar research. It's a very exciting opportunity. If you take a look, if you Google the NASA Lunar Meteoroid, excuse me, the NASA Meteoroid Environment Office, NASA Meteoroid Environment Office, you will see that they have a website that includes frequently asked questions, minimum system requirements, how you can actually get involved in doing this. And I want to personally encourage you to get involved. The more people we have looking over the wider range of the Earth's surface, the more of these impacts we're going to catch. And it's a pretty exciting thing. Typically it's done, people have video cameras mounted on their telescopes, and to get a video of this flash of a meteoroid striking the surface of the moon is a pretty darn cool thing indeed. We see Robert here has seen an example of a flash in the crater Plinius 3 years ago. So Robert, thank you very much. I hope you will continue to observe and put your observing skills to use. This is, and I think as Robert would probably agree, it's very, very, very exciting to see one of those events. Linda, why doesn't NASA make more of an effort to inform the general public about the current missions like GRAIL? Let's see. Yeah, people saying that NASA is dead and now that the shuttle has stopped. Well, as a matter of fact, the GRAIL launch was, I was down at the GRAIL launch. I was fortunate enough to be working there for the GRAIL launch at Cape Canaveral. And I can testify that there were thousands of people who showed up to watch the launch of GRAIL. So it was certainly not a secret, and it was webcasted and it was broadcasted, and I know a number of people who couldn't make it to the launch were actually enjoying it and seeing the launch. Yeah, especially when you take a look at the fact that we're about to have 5 spacecraft in orbit about the moon conducting science from the moon. To my knowledge, that's the first time that's ever happened. So, yeah, the space program is not dead, and lunar exploration is far from dead. As a matter of fact, I would perhaps go so far as to perhaps even qualify this as a golden age. We have here at the Lunar Science Institute, we have an annual Lunar Science Forum, and that is just becoming bigger and more exciting every year, and the public is definitely invited. So we are doing like I say, there's a lot of opportunity for people to watch launches and to observe what's happening. One of the great things about the GRAIL mission too is they actually have cameras on board that will be imaging the surface of the moon, and students will actually be involved in planning the, what on the moon gets imaged. So we have students that are going to be playing a significant role in the GRAIL mission. That's a lot of fun too. Let's see. Do we recommend a polarized filter or a colored filter for our scopes if you have one? It depends on the aperture that you're using, and it depends on the magnification. As you go to higher magnification, the moon's apparent surface brightness will get lower and lower. If you're using a large aperture telescope and a very low power eyepiece, then a filter is appropriate. One of the things that I really like are the cross-polarizing filters. So it's 2 polarized filters kind of threaded together, and so you can adjust, by turning the 2 filters, you can adjust the amount of light that comes in. You can just dial in the desired brightness. Yeah, having the moon on a screen right next to your telescope can be a very useful thing to do, especially if you have a large crowd of people there. It can beat having people stand in line for a long time. Pat's asking if there could be some sort of automation of detecting flashes on the moon. There are, yes. So the NASA operates Alamo, which is an automated observatory for observing lunar meteoroid flashes. And so, yes, that is in fact done. Very good. Oh, Andy, what am I missing?
Brian, I think you've hit them all, and it's actually getting to be about that time, about an hour. So um, I'd like to thank you for coming on. This was fabulous. We've had some great questions, and there's some pretty good chatter going on over there in the chat box as well. I would recommend to anybody, if you haven't already thought of this, I might see if we can do this for our event here in Houston, is to take the recording of this webcast and see if you just can't play it over and over at your event. Just a really, I think Brian, you just did a really great description of what people are going to be able to see that evening with some good, you know, introductory science explanations behind them. So, actually, Brian just asked if there's any way to get a PowerPoint, get this PowerPoint to use. Well, if Brian is willing to share that, yeah, we can post that on the ION website.
Absolutely. Absolutely.
Okay. Wow.
I noticed, Andy, there's a little bit of a font translation issue between my computer and yours. That's probably a PC Mac thing, so we should probably play with that perhaps a little.
Actually, might be a Connect issue.
Oh, okay. Very good.
It does that sometimes. So. Yeah, I'll just take the PowerPoint Brian sent me, and I'll put it up on the INOM site, probably um, under the science resources. I believe we have other PowerPoints. Actually, no, we'll go with event materials. There's a presentations section of the bottom of the event materials page on the INOM site. I'll put that in the chat box also, so everybody can go. Right, that's the link to the event materials page. If you go to the very bottom, you'll see a presentation section, so we'll put that PowerPoint there. And then once we have the recording for this, the link for this recording, we'll put that up as well into the multimedia section, and you'll have that as well. So thank you everybody again for joining us this evening, and many thanks to Brian Day for joining us this evening.
Thank you all very much.
Well, I hope you all have a good evening, and hope your events go well. And we're down, I believe, 10 days from INOM 2011. So good luck. Thanks for joining us tonight, and we'll see you all later.